Good morning, everyone. I don't know who's here, but if you are here, you got any questions, go ahead and type them in the chat. Good morning, Liberty. Good to see you. Oh, looks like there's two people. So Liberty, I know from Wednesday where we left off was you were in the middle of question 6 for the International 2017 International FRQ. So obviously today, just time to review. So any questions? It looks like I have more people than just Liberty. So any questions that you guys have, just go ahead and type in the chat. Good morning, first of all, to everyone else. Hope you guys are doing good this Friday morning. Oh, no problem, Rachel. Yeah, so Wednesday, I don't know, Rachel, let me ask you, did you watch the YouTube video by any chance? Or talk to Liberty to get some answers? Okay, cool. Just want to make sure, yeah, because Liberty has all the answers, and so yeah, if you talk to her and she helped you out, okay, then yeah, you should be good with those. Um, so I was thinking maybe like we've been doing is I'll go over question 6 on the 2017 FRQ, and then I'll give you the answers to the 2018 International FRQ problems 1 and 3. And that'll cover everything we did over the week, and then as I go through, if you guys have any questions, just mark down any answers you get wrong, and then we can just go back and go over the ones you get wrong. Was what I was thinking. So, if you haven't already, get open the 2017 International FRQ, and then go to question 6. So when you guys got that open, ready, let me know, and I'll begin to go over it. All right, Liberty's ready. Give Rachel's. Okay, cool. All right, so number 6A. Number 6A you should have gotten was pi over 12. So it's an improper integral. You're replacing infinity with t or b, whatever variable you decide to choose. Going through that process solving, you should have gotten pi over 12. If not pi over 12, the unsimplified version would have been 1/3 times pi over 2 minus 1/3 times pi over 4. Okay, for B, you want to use, well, you actually had a couple options. You had two really options that I could see. Regardless of what you chose, the two options I would have seen would be to use comparison test or integral test. Regardless of which method you chose, you would have gotten that the series converged. So if you chose to use the integral test, the reason why the integral test is smart is because you already did all that work in Part A. You already took the integral of that series anyways, or of the inside function, I guess. So like you did all the work from 6A. All you had to do was prove that you could use the integral test. Meaning you just had to prove that the series was continuous, positive, and decreasing. And for this one, there wasn't really much to prove. You could just say that they were, because it's just you can just look at it and you can know that. So I would think that the integral test would be the easiest. If you forgot how to do that, then maybe you chose the comparison test. I would assume you would have compared it to 1 over n squared, which converges and is bigger than 1 over n squared plus 9. So B of n is convergent and greater than A of n, which means A of n also converges. So those are your options for 6B. 6C was ratio test. So you go through, you do the ratio test, you should get 1 over e is less than 1, which means that it's convergent absolutely, or absolutely convergent. So I'll just stop there now, and then if do you guys have any questions on number 6? Or where you get for that? Rachel's perfect, all right. Awesome, awesome. Can you walk through 6A? Yeah, sure. So I think the difficult part here is something that you actually won't even need to worry about. So can we submit all that then once? Yes, Rachel. Once you have all the work done and you got the pictures taken, you can just submit it. The whole 2017 assignment. So I think the difficult part of this, Liberty, is the actual just integral. So taking like a general antiderivative is the difficult part. So you should have started by saying that the limit as t approaches infinity of 3 to t of 1 over x squared plus 9 dx. Okay, so that's essentially what you're evaluating, because instead of using an improper integral, you can change it into a limit as t approaches infinity of that integral. Okay, so now from here, the best way to do this, it's really, this is what kind of stinks about this part. Now, maybe what you notice is inside this integral, I have 1 over x squared plus 9. If you guys remember, the integral of 1 over x squared plus 1 is inverse of tangent. So the derivative of inverse tangent is 1 over 1 plus x squared. The integral of 1 over 1 plus x squared is inverse tangent. So these are correlating. We have a form that's very similar to that, but the one thing that we have is different is this 9. So that 9 messes things up a little bit. So what I'm going to do is I'm going to rewrite this, and I'm going to factor out the 9. I want to get this in a form so that I have x squared plus 1. Or so now it doesn't have to be x squared. It's 1 plus something x squared is what I'm looking for. So in this case, if I factor out a 9, I'm going to get x squared divided by 9, and then plus 1. Continuing on from here, okay, I still have my limit. Don't even have to worry about that. I can I can take out a 1/9. And I probably should have been smarter and prepared for that, but I kind of squeezed it in there. So I took that in front of the integral. And then I'm left with just 1 over 1 plus x squared over 9, or 1/9 x squared. And actually from here I can find what that general antiderivative is. So 1 over 1 plus x squared over 9. Okay, I know it's inverse tangent. The inside. Well, I know the inside is going to be something x squared. So the x squared, whatever that is, I know that x has to be in there. Like I know because x times x gives me x squared. So now I just got to figure out what times what gives me 1/9. And that's going to be 1/3. Okay, so if we were to go back through this, if we're reversing an integral, right, we're taking a derivative. So the derivative inverse tangent of 1/3 x is 1 over 1 plus 1/9 x squared. Okay, that's good. But remember, when you're taking a derivative, you'd have to then multiply by the inside of the function. So again, if I'm reversing this process, that would be that derivative. But I would have to do this correctly, it would have to be, this would also have to have a 1/3 in there, because the derivative of 1/3 x is 1/3 using chain rule, right? So to balance that, or to account for that, this is the trickiest part. And there's really no way for me to like give you a formula or give you like some cookie cutter way to do this. You just have to understand that when you take the derivative, it has to end up exactly what you started with. And so to do that, you'd have to also multiply by 3. So essentially, again, if I were to reverse it, if I were to take the derivative of this entire thing, it would be 3/9 or 1/3 tangent inverse of 1/3 x, which would be equal to 1/3 times 1 over 1 plus 1/9 x squared times 1/3. And that would get me to 1/9. 1/9 times that. So that's the tricky part, I think. I'll just stop there, Liberty. If you want me to keep going, I'll keep going. If that was the part of the question you were confused on, then I can just stop there. But just let me know. All right. I'm not sure if oh, there you go. Mariner's struggling right now. Okay. I don't know. Could you hear what I was saying, Liberty? Oh, I just got back. Okay. You can kind of see my work. I obviously, if you want to look back now that you're back, if you want to watch the YouTube video, just this part real quick, you can see my explanation. But let me ask you, in terms of the problem, was the issue just taking the integral from this step, or did you need to keep going? You think you caught it? Okay, cool. Did you need to keep going to evaluate this? Did that give you any problems? Because I know inverse tangent could be a little bit tricky too, but or were you good from there? Just let me know. All right, I'm thinking your internet's pretty lagged, so I knew that I needed to use the inverse tangent, but I'm not sure how to go about it. Okay, so yeah, this kind of shows you how we can approach that. Just to finish the problem off, you would just replace, right? You'd actually evaluate the endpoints, so you would do t over 3 times 3 minus 1/9 tangent inverse of 1 times 3. So this would be your limit you'd be left with. As t goes to infinity, this number is just going to get infinitely big, so it's basically tangent inverse of infinity. Well, that approaches pi over 2. So if you look at the graph of inverse tangent, it's always going to approach pi over 2. So we know it's going to be 1/3 times pi over 2 minus this tangent inverse of 1. You can just think of, okay, cosine over sine. What proportion of cosine over sine gives me 1? In this case, it's pi over 4. So it's 1/3 times pi over 4, right? Because square root of 2 over 2 divided by square root of 2 over 2 will give me 1. So that's where you get pi over 12 from. So I figured I'd mention that just in case. Okay, so let's keep going. So let's move on to 2018 FRQ. So go ahead and get that up and open. I'll go through the answers for number 1 to start, and then I'll answer any of your questions you have on it. So go ahead and let me know when you got your workout and the assignment open, so I know I can get started going over it. All right, Rachel's ready. All right, so I'm gonna get started. Maybe Liberty might be having some other technical difficulties. So the first question, so 1A, you should have gotten 1.35, and then the context of the problem, something like this. At time t equals 3 minutes, the rate at which grain is being added to the silo is increasing at a rate of 1.35 cubic feet per minute squared. So a big thing on that is units cubic feet per minute squared. It's increasing because it's positive, and the rest is given to us. For part B, you should have gotten approximately 160.8 cubic feet, or feet cubed. Again, 160.8 feet cubed. For C, you should have gotten approximately 61.749 feet cubed. 61.749 feet cubed. And then for part D, the amount of unspoiled soil is increasing at time t equals 6. Should have been your answer. Rachel, what was the integral in part B? Your integral in part B should have been the integral from 0 to 8 of g of t, which is equivalent. The equivalent statement for that would be in the actual terms of the problem is the total amount of grain added to the silo from time 0 to 8. Because the rate at which it's added is given by g of t, so the integral will give us the total amount. For part C, what you wanted to do, just to make sure, is you wanted to take the integral from 0 to 8 of w of t, which you could use your calculator for. That's going to give you the amount of spoiled grain. So you take your answer from B minus the amount of spoiled grain, and that's going to give you what amount of grain is not spoiled, right? Because G gives you the total. Well, the integral of G gives you the total amount of grain in general. W gives you the spoiled, so to get the unspoiled, you would take the total minus the spoiled. And then D, you're just taking G of 6 and W of 6, subtracting them, and then seeing if it's positive or negative. Okay, I didn't have any issues from 1, but I'm going to be honest here, I have not done 3 yet. Oh, okay. Well, go ahead, Rachel. You can work on it now if you want. It's not due till tonight, so it's okay. But yeah, if you work on it right now, I'll be here to answer any questions, so. Yep, no problem. Can you go over A and B so I can see if I'm doing this right so far? Yeah, absolutely. All right. So 3A, so this is 2018. It just simply says find f of 7 and f prime of 7. So to find f of 7, they give you what f of x is. So I just replace x with 7. So instead of 3x, I have 3 times 7, so 7, 14, 21, plus the integral from 0, instead of x is 0 to 7, of g of x dt. So f of 7 is equal to 21 plus, and then I'm just finding the area underneath the curve from 0 to 7. So essentially you're finding the area under the semicircle and then the area under that little line. Okay, so from 0 to 6, it's a semicircle. So you're going to do 1/2 pi r squared. And you're going to get, this case it's negative because it's underneath the x-axis. So it'd be negative 4.5 pi or 9/2 pi. And then you have to add the last from 6 to 7. So the area under that curve from 6 to 7, which is just a rectangle with length of 1, width of 3, or width of 1, length of 3, however you're looking at it. And you take that area and that's 3. So you're going to add 3. So 21 plus 3 is 24 minus 4.5 pi. Whoops, I don't know why I did that. Sorry, circling the whole thing. That's your answer for f of 7. Now what we want to do is we want to find f prime of 7. So I started off by just finding f prime of x. So you're taking the derivative. Hold on. And the derivative of 3x is 3. The derivative of the integral from 0 to x of g of t. If you're taking the derivative of that, we're going to use the fundamental theorem of calculus, which tells us that it's just g of x. So that's part 1 of the fundamental theorem of calculus. All right, and then that's going to be essentially leading into finding f prime of 7. So it's going to be 3 plus g of 7, which is 6. Right, get g of 7, you just look at the graph of g, and at 7 the point is 6. Or sorry, the point is 3. Okay, so that's 1a, or 3a. 3b says to find the value of x in the closed interval from -4 to 3 at which f attains its maximum value. So if we're looking for a maximum value, we're essentially looking for this, right? F prime of x. Okay, to find a maximum value, we're looking for when it changes, when a derivative changes from positive to negative, or increasing to decrease, and that's a maximum point. Okay, so we're going to take f prime of x. We know the fact that f prime of x is equal to 3 plus g of x. Now, there really is no formula for us to use. Like, we're not using the candidates test. We're not setting it equal to 0. We don't need to do all that. Now we just kind of have to use just common sense for this one. So we have our interval, right? -4 to 3. And let's take a look at some of this, okay? So essentially what I'm thinking about is any single value, okay? So from -4 to 3. Let's just start with -4. If I were to find f prime of -4, I'd be looking at g of -4. Well, g of -4 is positive 2. So positive 2 plus 3 is positive 5, which means it's increasing at -4 because the derivative is positive. Okay, in that process, I'm going to continue, right? Anywhere I see there's a positive value on g, that's always going to be 3 plus a positive number is always going to be greater than 0, which means that it's always going to be increasing. So then you look at from 0 to 6. Well, I don't even look that far. 0 to 3. The lowest I get is -3. So that's the only possibility at g of 3. That's the only possibility where potentially this derivative could turn negative. And it doesn't, because g of positive 3 is -3. And 3 plus -3 is 0. So Essentially what I'm saying is you should find that it's increasing the entire interval. So from -4 to 3, that function is going to always be increasing. F is always increasing. Meaning that if you have a function that's always increasing, the maximum value occurs at the end of your interval. So in this case, occurs at x equals 3. Now after 3, it actually still keeps increasing, but the question only asked us, okay, from -4 to 3, what's the maximum value? So your answer would be at x equals 3. Or sorry, what is it? The question says, find the value of x. Yeah, so your value of x is x equals 3. The justification is kind of just everything I just said, Rachel. You would just write that in sentences, right? How was that for you? Yep, awesome. Okay, sounds good, Rachel. Give me 1 second here. All right. So same thing. I'll go over the answers to C and D, and then you let me know if you want to go over it. So for C, the limit as x approaches 0 from the left. Oh, hey, Liberty. Good to have you back. Hopefully everything figured out. For C, the limit as x approaches 0 from the left of g prime of x was equal to negative 1/2. And all you're doing for that was finding the slope left of x equals 0. So it's a line, so you just find the slope of the line that gives you the rate of change. The limit as x approaches 0 from the right of g prime of x does not exist. Now, you didn't need any answers for these, you didn't need any explanations for these. It doesn't ask, so you don't really need to say anything. But the reason why it does not exist is because it's a vertical tangent line. So from the right of 0, it kind of looks like a quadratic curve a little bit. It's gonna head straight up. So that slope at a tangent point would have been vertical. And vertical tangent slopes, there's no way for us to tell. Again, though, you didn't need an explanation for that. D. So D, you should have found, there's a couple different steps to this. So you needed to find f of negative 2. That would have been important. And when you did that, you found f of negative 2 was equal to negative 7. So when you're taking the limit as x approaches 2 of the numerator, it's going to be negative 7 plus 7, which is going to give you 0. If you direct sub in the denominator for negative 2, you're going to get e to the 0 minus 1, which is 1 minus 1, which is also 0. So essentially what I'm saying is you have to prove it's indeterminate. That's your first step, 0 over 0. Say it's indeterminate. And then from there use L'Hopital, so you get f prime of x is equal to, the limit as x approaches negative 2 of f prime of x divided by 3e to the 3x minus 6. Do direct sub again. So the second time you're direct subbing, you need to find f prime of negative 2. When you do that, you find f prime of negative 2 is equal to 4. You could just use the formula you found in Part B or Part A. And then create that fraction, you end up getting 4/3. All right, so those are your last two answers. How'd you guys do? Yeah, no problem. So just so you guys know, like Rachel said, submit your 2017 FRQ. Yeah. So Rachel, you'll submit the 2017 FRQ. I'll grade that at some point. And then the 2018 FRQ, we're going to continue into next week, so don't submit any of that yet. We're going to finish that up. So just have your answers, set them aside, and then we'll continue it on Monday. All right, well, that worked. About an hour, perfect timing. Hope you guys have a great rest of your day, and have a great weekend. I know we didn't get to talk too much, but I figured we get down to business today. So enjoy your weekend. Try to do something fun. Mix things up a little bit. Thank you. Appreciate it, guys. Good morning, Calc AB. How are you guys on this fine Friday? Good morning, Jasmine. Tired? Yeah, I was pretty tired too. I stayed up and watched the NFL draft last night. And I guess for me though, it's not really staying up. I would have been up anyways, but for whatever reason, it didn't really. It kind of gave me energy. I don't know why, but yeah, I couldn't really sleep after, so didn't get all that much sleep. So I'm a little tired. It's okay though, fighting through it. How are your guys' other classes going? Especially your other, if you're in other AP classes. Is school in general going all right? Because now that the fact of the life is that we're going to be doing this for a while. It's going pretty well. That's good. I'm always curious because like a lot of times I can, in class I'll just be able to hear you guys say it. I'll hear you talking about it and like I get to like kind of see how every other class is going and everything, but I never get to talk to you guys or hear from you. So I want to make sure everything's treating you well. I'm slowly losing any motivation to do anything. Yeah, Haber, I know for you especially, because you're in that situation being a senior, which, as everyone knows, you already have your senioritis kind of kicking in on top of it. But mixing in the fact that we're on online school, the grading scales changed, like all these factors, it's yeah, I don't blame it. It takes a lot of discipline to stay motivated and to stay focused. So I give you a lot of credit, Haber. Sticking in there, pushing yourself. That'll pay off, trust me. Good morning, Alexis. Looks like I got the usual crowd here. Guys, just so you know, I'm going to start off with, like I said on Wednesday, I remembered. So we're going to do Unit 6 FRQ, Part 2. Stackling, good to see you. So go ahead and get that assignment open, guys, now, and then we'll go over that. Morning, Peyton. So we'll start there, and then when I'm done with that, probably take me about, I don't know, 15, 30 minutes, somewhere around there. We can ask any questions you guys have through the week. If anyone was wondering, the Browns drafted an offensive lineman, which I was pretty happy about that pick. I don't know if anyone else cares or anyone else saw it, but I think it was a pretty good pick for us. I think we needed it. So I'm excited. So again, if anyone just funneled in, we're going to start with Unit 6 FRQ A. We're going to look at the second question. So we did the first question on Wednesday. We're going to work on the second question today, and then we'll do some review afterwards. Peyton, do you know what we are doing with computers and stuff? Do we keep them, or will it be a turn-in? And would that include our books too? Because I have a calc book still. Yeah, Peyton, that's a good question. And it's a question actually I haven't heard anyone talk about yet. So I think that's kind of everyone's on the page of like, oh, future us will figure that out. Definitely going to need books back. So I don't know what the process is going to be. I think the idea is hopefully by then it's like going to be some, I mean, we can't have school, but hopefully by then there's going to be a way where you can actually be around people more frequently, by June. I would hope there would be so basically what's going to probably have to happen is, I don't know, I'm just spitballing here. I'm guessing maybe they'll open up the school potentially, and maybe teachers are going to be able to schedule people to come turn in any sort of books. It's either that or you're going to have to just drop them off at my place. I don't really know. I guess you're going to have to figure that out. Future us will figure that out, but that's a good question. I'll see if I'll be on the lookout for an answer for you, Peyton. And then in terms of the computer, I got to imagine the same idea. I have to imagine you'll have to turn it in. Unless there's a for sure situation where you juniors, you guys are going to be for sure starting in the fall, we're not going to have school and it'll still be online. Maybe they'll say keep them over the summer. I doubt it, but I got to imagine it'll be the same idea. You have to somehow schedule yourself to a time to come to the school or just go somewhere and turn them in. That's my thought process on that, but no answer for you really. Okay, guys, about one more minute I'll give. If anyone else wants to hop in again, Unit 6 FRQ A, question number 2. You should see a graph of f prime with a bunch of areas on it. All right, so go ahead in the chat. Let me know if you guys are ready. Have your stuff open. Have your notes ready. So I know I'm good to start. Thank you, Alexis. Haver's good. Peyton's good. Jasmine's good. All right. So I'm assuming that most people are good. Okay, so let's take a look. Follow along with me on the question. So you got this this graph, like I said, this curve. It's not like a specific function. It's just a random function, random curve. But they give us areas of these curves, which is nice of them. And this is the graph of f prime. That's important. Not the graph of f, the graph of f prime. So it says the figure above shows the graph of f prime, the derivative of a differentiable function f on a closed interval 0 to 7. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 4 equals 10. Okay. They also say randomly, let g be the function defined by g of x equals 5 minus x squared. Okay. So those are all the pieces and parts they give us. Let's look at it. Find the value of the integral of 0 to 7 of f prime of x. Okay, so let's break apart what this is saying. This statement is saying what is the area under the curve of f prime from 0 to 7. A lot of times you guys see this type of question, I hope, and then hopefully we'll get to that point if not. And you should be thinking fundamental theorem of calculus. Why is that? Because I have an integral of a derivative. Whenever you have an integral of a derivative in your head, you want to be conscious of the idea of fundamental theorem of calculus, which uses this directly in the definition. Okay, but in our case, our situation is kind of nice because we actually, for once, generally we're given f of x, not f prime. We actually know what f prime of x is. They gave us the graph of that. So this question is just saying what's the area under the curve of f prime. And we have a picture. And the areas that are given to us of each individual portion is 2, -7, because it is 7. The area is 7, but it's below the x-axis, so we say -7, +3, and then +1. Add those together, your answer is -1. It's that easy. That's your answer. So again, you always want to look at an integral and say, what is it asking? It's asking me the area underneath the curve of f prime of x. You could also say it's asking you what f of 7 minus f of 0 is, but we don't know what f of 7 and f of 0 are because we're not given that function. We're luckily given the function f prime, which works in our favor for this question. So very, very, very straightforward question for part A. If you guys have any questions as I'm going, please just type them in the chat, and then eventually I'll look up and see it, and then I can just go back. But as I go, just ask any questions you have. That's part A. Part B says, given that f of 4 equals 10, write an expression for f of x that involves an integral. Use this expression to find the absolute minimum value of f and the absolute maximum value of f on the closed interval. Okay, so what we want to do here is split this up into 2 separate parts. All right, so this is kind of like 2 questions in one. All right, the first question is to write an expression for f of x that involves an integral. Ideally, really they could have just split this question up into 2 different ones because they're not really completely correlated anyways. I mean, they are, but, let's just focus on each piece. So let's focus on just writing an expression for f of x. So how can we do that? Well, let's look at this idea. Okay, they don't give us this f of 4 equals 10 for no reason. They do that for a very specific reason. It's telling us that, well, okay, we want to know what we know what f of 4 is, so use it. And so I need to write some sort of integral. Well, there's one thing I can write that I know, and this kind of goes back to 2a, because I mentioned when you see something like this, think the fundamental theorem of calculus. So for part B, we're actually going to apply it. I'm going to choose 4 as my lower bound because I know what f of 4 is. And I'm going to choose x as my upper bound because it says to write an expression for f of x, just a generic f of x, a generic x value. So why am I doing this? Oops. That should be f prime of t, dt. Okay, I'm doing this because of this. This expression, the integral from 4 to x of f prime of t, I know by using the fundamental theorem of calculus is equal to f of x minus f of 4. That's the fundamental theorem of calculus, part 2. So this isn't something I can just tell you guys, like, oh, just know to do this. Okay, and this is the whole reason I chose 4 is because I know what f of 4 is. So if I add f of 4 to both sides, I get f of 4 plus the integral from 4 to x of f prime of t dt is equal to f of x, which is what we were looking for in the first place, right? Yeah, and then so we can replace f of 4 because we know what it is. F of 4 is 10. So essentially I'm left with 10 times the integral from 4 to x of f prime of t dt equals f of x. Okay, so that's part 1. That was us writing an expression for f of x that involves an integral. As a reminder, guys, t, like this statement, f prime of t, this is still referencing our original function. So I know our original function was written as f prime, right? That can be assumed as f prime of t as well. Okay, f prime of x, f prime of t, they're one and the same in this case. Just t and x are just different values. All right, so that helps us then with the next part. It says use this expression to find an absolute minimum and an absolute maximum of f. Okay, when we look at relative minimums, sorry, Payne, I just saw your question. Why did you put the integral back in there? Is that what f of x is? Why did I put the integral? Why did you put the integral back in? Oh. Why did you put the integral back in there? Is that what f of x plus is? So starting up here, Peyton, this is the integral. I knew I had to write it f of x as an integral, expressed as an integral. So I started off with this integral because I knew that that was going to be equal to f of x, which I needed to solve for, and minus f of 4, which is something I already knew. And so I just added f4, so I didn't really add or put an integral back in there. I kind of just kept the integral in there. Yes, exactly, Peyton. That's essentially what we're saying here. Hopefully that answered your question. Okay, so continuing with what I was saying, we want to use this expression to find an absolute minimum or maximum. Whenever we see the word absolute minimum or maximum, we always want to think candidate's test. Just like when we see the words local or relative minimums and maximums, we were always thinking to set derivative equal to 0, find the critical points, and then use some sort of sign chart to get an answer. That's the thought process we got to keep having. So absolute minimum and maximum candidate's test. Well, part of candidate's test is we need critical points. Critical points occur when f prime of x equals 0. Lucky for us, we're given what f prime of x is because we're given the graph of f prime of x. Paying f prime of algebra? Yeah, no problem. So if you guys were to look at your graph of f prime, we can find when this is true. And this is true at x equals 1, x equals 4, x equals 6, and x equals 7. Okay, now one thing though is I do want to kind of eliminate one of these. Okay, so go ahead and look at your graph. When we're looking at critical points are when specifically we're looking for points at which the function goes from increasing to decreasing or decreasing to increasing. In other words, we're looking for when the derivative, it goes from positive to negative or negative to positive. At one point on this graph, it doesn't change. The slope is equal to 0, true, but it doesn't change. Okay, and that point is 6. X equals 6 we're not concerned about. Because at x equals 6, it's the derivative gets to hit 0, but it stays positive afterwards. So we know that the function was increasing, hit probably an inflection point, and then just kept increasing. So that point is going to be ignored. It can't be a maximum or a minimum. So when we're looking at these absolute maxes and minimums, we're only looking for the critical points where it changes from increasing to decreasing. So I'm getting rid of x equals 6. Now I'm going to use the candidates test. So I need to check the endpoints and my critical points. So f of 0, f of 1, f of 4, and f of 7. Okay, remember guys, I just found an expression in the blue here. I know what f of x is. Right, I circled that in blue. So when I'm finding f of 0, I'm just taking f of x and I'm replacing every x with 0. So 10 plus the integral from 4 to 0 of f prime of t dt. If you'll notice, right, this is from 4 to 0. That's not right. Our lower bound needs to be at the bottom. So to account for that, we put a minus out front and switch the bounds. And then we solve. So how do we find the integral of the derivative? Well, we look back at the original equation, or sorry, the original graph. So from 0 to 4, it looks like we have 2 minus 7, which is negative 5. 10 minus negative 5 is equal to positive 15. So I'm just going to kind of lightly highlight that just so we know that it's there. Okay, and we're going to keep doing this process. It's going to keep happening. So this is going to be 10 plus the integral from 4 to 1 of f prime of t dt is equal to 10 minus the integral from 1 to 4 of f prime t dt, which is equal to, you look at the integral from 1 to 4, it's just negative 7. So it's going to be 10 minus negative 7, which equals positive 17. Please stop me, guys, if you get confused at any point during this. F of 4 is just 10 plus the integral from 4 to 4 of f prime of t dt, which is equal to 10. Because that area underneath f prime from 4 to 4 is 0. Oh, thank you, Paid. Completely forgot about that. See, that's why I need you guys, because I would have been just kept writing away. Sorry, let me highlight back again what I did. So this is f of 1, replacing 1 as my bounds. Flip them and put a negative out front, because I want my lower bound to be at the bottom. Okay, looking at the graph, this is negative 7, the area underneath that curve. So 10 minus negative 7 gives me 17. For f of 4, it's 10 plus the integral from 4 to 4. Any integral that has the same upper and lower bound is always 0. So 10 plus 0 is 10. Alright, and then f of 7 is going to be 10 plus the integral from 4 to 7 of f prime of t, which is equal to, well, looking back again at the original graph, from 4 to 7 it's 3 plus 1, which is 4. So 10 plus 3 plus 1 is equal to 14. All right, and that's every piece and part we need. So the actual question asked us to find the absolute minimum and absolute maximum. So we're just looking for the biggest and smallest points. So my absolute maximum is going to be 17. And my absolute minimum is going to be 10. I love my red, white, and blue here. I guess I don't have white, but the paper's white. Very patriotic of me today. That's the most patriotic calculus problem you guys will ever see. I guarantee it. Mr. USA Harris, that's what they call me. All right, so that was a lengthy part B. A lot going on there. I know I kind of took it pretty slowly, but I think that's good. It benefits you. So again, I'm gonna be looking at the chat. So go ahead. I'm gonna move on, but go ahead in the chat and type if there's something you guys didn't get with that, and I will go back and address it. But for now, I'm assuming you're all good on that, and we're going to go to C. And C's, after all that work, C just says do that. Find the indefinite integral of g of x. It's been a while since we looked at this. This is good. Okay, I know what g of x is. The original question gave me what g of x is. It said, like, pretty quickly in the problem, it says that g of x is equal to 5 minus x squared. So if I'm finding the general antiderivative of g of x. It's just the indefinite integral of 5 minus x squared. And this is obviously dx. And then you're just going to take these general antiderivatives. So the antiderivative of 5 is 5x. The antiderivative of negative x squared is negative 1/3 x cubed. And then plus c. That's all it is. So you just go from part A, really quick, easy, bam, done. Part B took forever. Part C, very quick and easy, bam, done. This kind of goes back to when we first started integrals, indefinite integrals, when we first learned about those. This kind of part C really highlights that. And of course, you guys can't remember to add the c. You only add c with indefinite integrals, meaning no bounds. If you have an integral with no bounds, you always got to add c. All right, part D. This is what the question's asking us. I went ahead and just replaced g of x with with what g of x actually is. I just figured I'd get that out of the way now, which you didn't need to do, but for me this was the easier way to do it. I always like to do that. Now, important part of this question, right, is the fact that we do not have a calculator. So the fact that we don't have a calculator, and we don't know what the actual function of f prime is either. So like those pieces put us together, and we're like, okay, now we're kind of in a situation. Okay, I have a product of a function times the derivative of a function. In this second part specifically, it's a composite function. So I have x times a composite function. This is the perfect setup for the definition of u substitution. Maybe you guys see that right off the bat. If not, I understand. It's not always readily apparent, but this is, if you look at the definition of u substitution, this is it. It's some function times f prime of a function, where x can be a derivative of whatever's on the inside of the composite function, which in this case is true. So I told you guys, we're always using u sub when you have a really complicated integral that you don't know how to solve. That's always at step one. That's like the first thing, because you have, when in doubt, you sub it out. That's what I say. And you're looking for a difference of 1 in variable exponents. So like this is x squared and this is x. So because I know when I make a u sub and take a derivative, x squared will turn into something x, which is a good sign. So by now you can figure out what I'm getting at here, and that's the fact that we need to use u sub. We always let u equal the inner function of the composite function. So in this case, u is going to be equal to 5 minus x squared. Take the derivative of both sides. I get du equals negative 2x dx, or x prime. Some people do it differently. You could do u prime equals negative 2x x prime. I prefer not to, but which means if I divide by negative 2, I get negative 1/2 du equals x dx, which is good for me because you guys can see in my red box, I can replace x and dx now with negative 1/2 du. Now, if you guys remember, there's one other thing I want to change. And I don't have to do this, but I want to do this because I think in this problem it's going to be our easiest way to go about solving it, in my opinion. And that's changing the bounds, because now I change this entire inside function in terms of u. Okay, I have this part, and I have this part. But what I need to do is take this idea and change the bounds to also be in terms of u. So at x equals 1 and at x equals 2, u is equal to 5 minus 1 squared, which is 5 minus 1, which is 4. At x equals 2, I don't know why I did that. At x equals 2, u is going to be equal to 5 minus 2 squared, which is 5 minus 4, which is 1. which is 1. So those are going to be important to us. All right, so now I can rewrite this integral. This is going to be equal to the integral from, instead of x equals 1, we're going to do u equals 4. So my lower bound's 4. At x equals 2, instead of that being my upper bound, my new upper bound is u equals 1. So 4 to 1. Instead of x dx, I now have negative 1/2. And then du. I like to put the du at the end. You don't need to, but for me it helps. And then you still have an f prime. And in this case, instead of 5 minus x squared, you have u. Now I want to go through and actually solve this. So that's going to be equal to, you take out the negative 1/2, the bounds from 4 to 1, of f prime of u du. Hopefully you see these bounds and that bothers you, as it should. That's not less than 1. That should be my lower bound, so 1 should be down here. To account for that, I take a negative 1 out front, which makes this a positive 1/2. I flip the bounds, and I'm left here. Now the area from 1 to 4 is negative 7. If you look at the graph of f prime, the integral from 1 to 4, the area underneath that curve is negative 7. So I just have 1/2 times negative 7, which equals negative 7/2. And that's my final answer. That's why changing the bounds was so useful, because when I change the bounds, I don't have to go through that process of replacing back into x and then solving that. It just would have been a pain in the butt. So in this case, like I really think your best option for sure was to change the bounds of u. So I know that was a lot, guys. Let me know if you have any questions. Give you a couple minutes to process, to finish copying down the notes, and then go ahead and fire away in the chat if you have any questions. Jasmine says she's good. Thank you, Jasmine. Anyone else good or need help or anything? Thank you, Alexis. Alexis is good. How about the rest of you guys? We happy? I'm going to take the silence as yes, we're good. Or no one's listening. All right. Well, if that's the case, then we're good to move on from Unit 6 FRQ Part A. I'm open now to any questions you guys have from anything. So anything we've done this week is now fair game. Go ahead in the chat, just type a question you have, and I will get to it. Yeah, Jasmine. Again, it's just up to you guys. So if you want me to just give you the answers, and then you can check your work, and then see if you have any questions based off of that, we could do that. If you guys like that idea. If someone has specific questions, so like Haber, okay, D from Unit 6 FRQ. Can we review the answers for Unit 6 Part B just to see? Yeah, okay. So I think that's a good idea, Payne. So go ahead and get Unit 6 FRQ Part B out, guys. Get the assignment open and your notes out. Even if you didn't do it, because it is due tonight, but even if you didn't do it, guys, you can at least, like, as I go through, you can write the answers at the top of your page or somewhere on your page. So that way when you go and actually do the assignment, it could help you out. And you can reference the actual answers to see if you're doing things right. So that would be my suggestion. But you can do, what works for you. I can see the amount of people who did it and who kind of has started, or at least looked at it. Not great. It looks like only 9 of you guys have even looked at the assignment. And there's 8 of you in here. So I'm assuming it's probably you 8 who have looked at it, just based off of how things usually go. So I'm not really worried about you guys. So I'm sure you all have looked at it and have started it. Okay, so let's get started. So this is Unit 6 FRQ Part B. These are asking about approximations, Riemann sum approximations, and then some other stuff based off of that. So 1A, I'm trying to open up the assignment so I know exactly what the question was saying. It's probably going to take a while to open up. Okay, so 1A says to approximate the definite integral from 1 to 3 of f(x) using a midpoint Riemann sum with the subintervals 1 to 1.6, 1.6 to 2, and 2 to 3. Okay, so we're using a midpoint Riemann sum. That's important. So we're thinking rectangles that the height is going to be based off the midpoint of the interval. We're approximating a definite integral. We're not too worried about that. So this is what we're essentially saying. Okay, and you can use a calculator for this, by the way, too. So you guys go through, you did the midpoint, you need to find the heights in each interval, the heights of each rectangle in each interval, and then you need you to find the width of each interval. Put that all together and you should get 0.331. So your area should be approximately 0.331. Part B was similar, except this time you're using a trapezoidal sum. So we're approximating using trapezoids. And then you have different subintervals now. You have 1 to 1.6, 1.6 to 2, and 2 to 3. Never mind, those are the exact same intervals. I lied, sorry. You have the exact same intervals. So the widths should all be the same. The same widths you use for A, you should use for B. The only difference is going to be now to find the actual areas of the shape. We're not using a rectangle. It's not just base times height or length times width. In this case, it's using area of a trapezoid, which you have the base, the first base times the second base divided by 2, all times the height, in our case, or the width. However you want to look at it. And so you do all that, get your answer, should be approximately 0.342. Again, 0.342. Part C said it is known, it gives you what a derivative, the derivative, and second derivative f are. Would a trapezoidal sum approximation for 1 to 3 of f of x overestimate or underestimate the value of f of x? Give a reason. Whenever we're looking at overestimations and underestimations, we're always going to be looking for concavity. Concavity gives us a lot of information. Because if we're using this, let me actually just do this real quick. Like a very, very basic, quick review of this. I'll just use a pencil. You see that? Okay. That is concave down. And I'm just making something up. This is not going to be like an actual... Okay, so this is just like pretend like I was estimating this area using those rectangles, right? What you can see is I'm missing like little bits and pieces. Missing a piece there, there, a little bit up there, right there, and then, so on. So I'm underestimating, right? Because there's parts of the area that I'm not accounting for. So whenever it's concave down, it's an underestimate. Whenever it's concave down, it's an underestimate. If you have something that's concave up, such as this. So very, very simple explanations. But you would be drawing this a little bit differently. So in this case, it's really hard to do when there's, this is not a good graph. Let me just do like part of that graph. Let's just do that. So if I'm drawing these intervals, let's say to here, then I'm going to go up and over, up and over. So something like this, you're going to see now I'm overestimating. These points in the black would be an overestimate. Now I know this wasn't like greatly drawn, but at the end of the day, point being is concave up, you want to think overestimate. If you ever are confused or ever like are thinking yourself, you can't remember which one's which, obviously you have it in your notes now, so that helps, but if you're ever confused, just drawing pictures sometimes can help. All right, and obviously my picture was very quickly drawn and wasn't very good, but you get the gist of it. So anyways, that's all I need to know then is concavity. Concavity deals with the second derivative. So in this case, f double prime of x, where is that greater than 0? So from 1 to 3, is that greater than or equal to 0? And it is. F double prime of x is greater than 0 for 1 to 3. How can I find that? Well, you can just put in your calculator and graph it. So in your calculator, you just throw in f double prime of x, toss that in there, just look at the graph. Is it positive or negative from 1 to 3? It's positive, so it's concave up, which means it's an overestimate. The trapezoidal sum is an overestimate. And part D was a little bit complicated. We want to write that integral as a limit of a right Riemann sum. So this is going backwards from what we did with 6. Was it 6a? Yeah. So 6 from FRQ 6 Part A, the first question, we did something exactly like this, except we found the integral instead. So now we're going backwards. We're taking the integral and we're finding the Riemann sum. So to do this, you guys wanted to find your endpoints, what each endpoint was going to be. You wanted to find the height. A general equation that represents the height of each interval. And then put that all together, and your final answer should be the limit as n approaches infinity of the Riemann sum from I equals 1 to n of cosine of the square root of 1 plus 2 over ni, and that quantity times 2 over n. And I know I'm definitely going to do that question. So part D, I'm definitely going to go over. So if you guys have a question on that, don't even bother putting it. But if you have a question of A through C in the chat, go ahead and let me know. And part C, I actually already pretty much gave you everything. So part C, I guess you shouldn't have any, unless you need me to reiterate. Peyton, I'm just going to go over the question, so you'll see it on paper. I know what people want to look at that one, because that one's challenging for a lot of people. So any questions from A and B, primarily? Okay, so let's get started then on this question. So 1D. This is Unit 6, FRQ B. Okay, so again, question's not very long. It just wants you to write an integral as a limit of a right Riemann sum with n subintervals. So first things first, if we're going to write a Riemann sum, remember a Riemann sum is just a notation to express the sum of a bunch of areas. So in order to do that, I need to find a generic formula that represents finding the areas of every single interval or subinterval. And to find every single area, this is a right Riemann sum, so it's rectangles. So I need width and I need height. I have to find those. So let's just start with just width. Now this isn't just straightforward. It's not cut and dry. It doesn't say that you want to find the area from 1 to 3 with 3 equal subintervals or anything like that. It just says n subintervals. So if we're going to find the width of each individual interval, what we need to do is we need to take the length divided by the number of subintervals. Which makes sense. You take the total length of the entire place or the entire interval of what you're trying to find the area of. And if you divide that by the number of subintervals, that's going to give you the length of each individual subinterval. So the total length is from 1 to 3, which is 2. The number of subintervals is given to us as n. So that's going to be define the width of every single subinterval. So every rectangle we're summing has a width of 2 over n. All right. So we got the width. Now we need to find the endpoints. We need a general formula to represent every single endpoint. And to do that, I told you guys this when we went over this. It's the beginning of the interval plus the width times the variable I. The beginning of our interval in this case is 1. So it'd be 1 plus the width we just found was 2 over n. And then times I. I'll just leave it like that. All right. Now again, like I said, to find the area of each individual rectangle, it's not the width times the endpoint. It's the width times the height. Well, we needed the endpoint because the endpoint is going to give us the height of every single subinterval. To find a height, when we're looking at a graph and we're looking at functions, to find the height, we take f of whatever that endpoint is. So we need to find what f of 1 plus 2 over ni is. And we just plug that into original equation for f, which was cosine of the square root, in this case of 1 over 2n times I. Now that is going to be our height of every single subinterval. Every single rectangle, the height can be used with this formula. We just got to plug in what n is and I is, which we don't care about. That's not of our concern. But this is good for us, right? Because now we have a width and we have a height for every single rectangle. So to get the actual area, we sum up infinite amount of those rectangles. So we put the two pieces of red together, and we get the summation of I equals 1 to n. I start at 1 because it's a right endpoint Riemann sum. So I is always 1 with right endpoint Riemann sums. And this summation is the area of each individual rectangle, so it would be cosine of the square root of 1 plus 2 over n I, which, as a reminder, right, that's the height, and then times the width. Width times height gives me the area of the rectangle, and the width we saw was 2 over n. The actual question, if you guys go back to the actual question, it asks you to write the integral as the limit of a right Riemann sum. That's my right Riemann sum. The definition of an integral says to find it, you would take the limit as n approaches infinity of that Riemann sum. So I just got to add that limit notation out front, and bam. That's your final answer. Should be a division sign there. So 2 divided by ni. I know those ones can be a little bit challenging, so please, if you guys have any questions, go ahead and ask them now. Haber, patented thumbs up. Thank you. So I know Peyton, you asked on Wednesday if we have some more questions that were similar to that. This is an extremely similar question to what we did on Wednesday. That was very complicated. The only difference is that this reversed that, right? This took what we did on Wednesday and just reversed the process. So instead of giving us instead of giving us this, we were given an integral. So if you guys want some extra practice, what I'd recommend doing is try to go from here and work backwards. So think to yourselves, how can I go from here back to the integral? Even though you know the answer, right, because they give you what the integral is. You basically want to say, how can I work from here backwards? If anyone's curious, if I said that and you're like, oh, I don't really know how to do that, it'd be just replicating what we did for Part A, for Unit 6. Right? So we would need to know that, the idea, this is the width. So the width would be equal to 2. You don't have to write any of this down, but you can follow along if you want. The width is 2 over n. So the total interval is when n equals 1, right? Because we're thinking the idea of just creating one rectangle. That would cover the entire interval. So when n is equal to 1, which means that the length is equal to 2 over 1, which is equal to 2. If you guys notice, we started with the integral from 1 to 3 of f of x dx. What do you notice about this 1 to 3? That's a length of 2, right? So, like, very simply put, that would be how we could find. We go backwards if the question asked us to. If we were given this in the red, and we had to go backwards. All right. Are we good? We have 7 minutes. We don't have too much time left, but I think that covers everything we need for your homework from Wednesday. We finished up Wednesday's notes. Monday's Unit 5 FRQ Part B, we did go over a couple questions from, so most of that we already covered as well. So I think that pretty much gives you everything you guys need, but you still have 7 minutes, so any questions you guys have, I'm here. And if you don't have any questions and you're about to leave, then I hope you have a fantastic weekend. Thanks for stopping by. You do have homework over the weekend. It's an assignment. It only has one, FRQ Part A. It only has one question on it. So it shouldn't take you guys a whole lot of time. Same thing as always, guys. The homework you can submit. So anything you haven't done, it's due at midnight if you haven't done any assignments. Make sure you submit them to College Board. Don't email me if you don't have to. If you guys are having problems with College Board, whether you can't post pictures, whatever it may be, we have to get that figured out. So I've been so far I've just been like, oh, just email me, that's fine. We have to get a solution to that because for the AP test you have to take this online. So it needs to work. So we gotta get to the bottom of that. We might have to call the tech guys, whatever it may be, but if that's the case, if you're in that situation, let me know. Andrew, I just saw your email. Thank you. I don't know why. Yeah, I don't see any questions from you. So let me read your email real quick. It looked like it was referenced to what we were doing right there. So guys, in the chat you can't see, but Andrew asked me. Let me load it real quick. He said, I don't think the chat has let me speak. I'd asked, how would that look if it were a left Riemann sum or in front of you? Okay, so that's a great question, Andrew. So let's look at this, guys. How would this be different if it was left? Let's start with the width. Would the width be any different? No. Your length is still 2. Your number of subintervals is still n. Okay, so Andrew, your first part, to answer your question, step 1, basically, good. Nothing changes. Step 2, the endpoint, beginning of the interval plus width I. Okay, well, the beginning of the interval is still 1, and the width is still 2 over n, and we still have times I. Nothing changes. Okay, so step 1 and 2, nothing changes. The height is still going to be f of the endpoint, which is still cosine of the square root of 1 plus 2 over ni. So then nothing changes there. So we're doing really good. Then we get to the limit as n approaches infinity. Here's the only difference, and now this is where it gets a little bit, have a good weekend, Haber, thank you. This is where it gets a little bit different. Obviously, something has to change, right? We would change the I, because if I were to plug in 1 for I, let's look at the endpoint. If I were to plug in 1 for I would get 1 plus 2 over n, 1 plus 2 over n. That shouldn't be true, right? If we're having a left endpoint, shouldn't our very first endpoint be at 1 because that's the beginning of our interval? So what you want to think to yourself is, okay, what would I have to plug in for I to make this 1, to make my first endpoint 1? In that case, it's pretty clear, right? If I is 0, then I'm left with 1. So we would have to change your beginning of your summation as I equals 1, which would also mean that I don't end at my final endpoint. So I shouldn't end at 3, because if I plugged in n for I would get 2 over n times n, which is equal to 1 plus 3, which would make sense for that being my last endpoint for a right endpoint. But for a left endpoint, that shouldn't be my last endpoint. It should be 1 less than that. Sorry, not 1 less than that. 1 less than n. So my final of your summation notation, your end term is going to be n minus 1. That would be your final left endpoint. Now I know that was a lot, Andrew, and I know that might have sounded a little bit confusing. I don't know if you can answer back in the chat if that was okay for you. You can try, but if not, just email me. Let me know if that was okay, if that made sense. Great question, though. Very, very good question. So at the end of the day, the only thing that changes is you always start at I equals 0 for left endpoint, and you're always going to end at n minus 1 instead of n. That's the short of it, okay? Hopefully that helped. All right. Well, yeah, guys, about algebra time. So I really hope all you calculus students have a great weekend. Please don't hesitate to email me if you have any questions over the assignment. I'll get back to you as soon as I can. Try to get everything submitted by tonight, 11:59, I think it is. Try to get all the assignments from this week submitted, so I have them, and I'll probably start grading them next week at some point. I'm almost done grading your stuff from. All right, you're welcome, Andrew. I'm almost done grading your stuff from last week, just so you guys know. So check your grade books. You'll be seeing some of that stuff soon. You too, Stacklin. Thank you. Appreciate it, guys. Thanks for stopping by. All right, if you are an algebra student, let me hear you. Let me hear you in the chat. Whoop, whoop. Let me get some feedback. Where are my algebra people at? Don't want to scare you guys off. Let me just flip that notebook there. You don't have to see that calculus stuff going on. Good morning, Jay and Dudek. How are you living today? Got any plans this weekend, Jaden? You're the only one I can talk to right now because no one else said anything. I'm doing good. I was a little bit tired. I'm getting a little bit of second wind. Had a lot of calculus questions, a lot of work, so that was good. Keeps me going. I took some allergy medication. My allergies were kind of acting up this morning, so I'm gonna be pretty worn out because I don't know why. It's drowsy. It's not the non-drowsy stuff. I need to get like the non-drowsy. So it makes me a little drowsy. So I'm gonna have to be fighting that a little bit, but that's fine. It's Friday, right? Got the weekend coming up. We should be happy. Had a cup of coffee already and drinking another. All right. There you go. You're the coffee guy in my classes, Jaden. Keeps you functioning, right? Is it just Jaden? I wonder who else is in here. I am helping my uncle build a shed. Very cool. Man, I wish I was helping. I wish I had someone to help build a shed. That'd keep me occupied for a little bit. Right now, it's kind of been a haven't done any manual labor in a while. Which usually I am, because like my parents, my dad's got a bad back, so he doesn't like to do too much like heavy lifting. He's more of a, at this point in his life, he's kind of just like tells his kids what to do, meaning me and my brothers. So a lot of times I'm over my parents, like helping with random stuff, whether it's putting down mulch or moving stuff to the attic, whatever it may be. I'm usually like the heavy lifter. But I haven't done that in a while because of the whole corona and everything. There's not much to do. So it's kind of nice, It might be hard work, but it's nice to hang out with your uncle and have something mindless to do a little bit. Then again, building a shed isn't really mindless. That actually takes some thinking. Who else is here? There's 5 other people. Stop being shy. If you're in Algebra 2 and you're in this chat right now, go ahead and say something. Tell me your favorite color. I don't care. Put something. Make things a little bit interesting on this Friday. Bunch of shy people. Like I'm gonna get mad at you. Oh, Mr. Harris, I just woke up at 11 o'clock. I'm tired. I didn't want to put anything in the chat. Come on. People. Weak. Don't be weak. 6 people now. And only 5 likes, by the way. That's a crime. That's criminal. I gotta have a talk with Calculus because they slacked today. But I know my Algebra 2 students, you guys are always boosting my likes, which I appreciate. But now I'm just like, I'm feeling a little let down right now. There you go. Someone's listening. I don't know what these other 5 people are doing, Jade. I'm assuming you're the one who smashed that like. Unbelievable. You guys are just doing this to make me mad, I think. Tell me I got 6 viewers and only one of you is going to talk in the chat. What a shame. I will say, though, I did have someone in my last class having issues with the chat. So if you guys are having issues with your chat, if I keep talking and I'm like, well, you guys aren't putting anything in the chat, and like you've been trying but it's not letting you, there you go, Jaden. Then go ahead and email me and just say like, hey, Mr. Harris, chat's not working, because I don't. It looked like it was working for some people in calculus, but maybe not all of them. So. Jan, you absolutely demolished that like button. All right, well, Jaden, I guess I'm just talking to you today. You have any questions on anything from the assignments? Anything you want to look over? You want to do a hangman, just you and I, Jaden? All right, that's fine. You think of the category, though. You don't have any questions? All right. We can still do a hangman if you want. I'm going to be on for an hour anyways. Give me a category. We'll do one up. Hey, Jonah. All right, Jonah, so here's the deal. I'm going to give it a little bit of time because technically this is for algebra, and I want to make sure like everyone's good. So we're going to do this hangman, Jonah. Feel free to participate. But afterwards, if no one from Algebra 2 has popped in and asked a question on the stuff, then we can go to calculus and do one of your College Board stuffs. But first, I got to make sure Jaden's all good and he has no questions. If you want, though, Jonah, go ahead and type it in the chat right now, and maybe I can give you some guidance while you're waiting that might help you out. So just be like, oh, I'm working on this problem. Here's what I got. This is what I'm thinking. If you can give me that in the chat, maybe I'll be able to give you a good direction. Unit 6, Part B, questions A and B. So actually, Jonah, here I'll tell you what. I don't know. I don't think you can. I was going to say, if you can rewind my stream, that'd be perfect. Actually, never mind, because I didn't go over those. So I don't know if you were here during my stream, Jonah. I went over the answers. Did you hear that, or do you want me to give you the answers or to double check you're okay? Or are you positive like you don't know how to do them, you didn't even start them? So I guess kind of just tell me where you're at with the problem. Because I know during the stream I went over the answers, but I'm not sure if you were in there or not. Okay, no problem, Jonah. That's fine. I'm not seeing anyone from algebra saying anything. So if you are on algebra and you're hearing me right now, go ahead, guys. I'm not. This is still your time, but I'll help Jonah out because I don't really see anyone else here. So here's the deal, Jonah. You have. Let me scroll down. So this is going to be just 1A. Okay, and it asks you to do a midpoint Riemann sum with intervals, a bunch of different intervals. Let me see if I can pull the assignment back up. But you have this f of x is equal to cosine of the square root of x. So that's given to you. The question wants you to approximate the integral from cosine of the square root of x dx using midpoint Riemann sums. So here's how you do that. Hold on. I don't remember if it was midpoint or not. Let me pull up the assignment. I felt like it was. Maybe I was wrong. Yes, okay, it was at midpoint. Perfect. So here's what we got to look at then. Finding midpoint Riemann sum. So it says that we want to use 3 different subintervals. So essentially we got these 3 intervals. So from 1 to 1.6, 1.6 to 2, and then 2 to 3. Those are the intervals that we're working with. And we need a couple pieces of these intervals, a couple important pieces. So first things first is we need the width of each. Because if we're finding the area of each of these Riemann rectangles, we need the width of each rectangle. Well, the width is going to be the total width of the interval. So in this case, it's 0.6. In this case, it's 0.4. And in this case, it's 1. That's pretty easy. Now the height's a little bit different. So the height's going to use the midpoint for every single interval, meaning I have to find the midpoint, the function value at each midpoint. So the midpoint between 1 and 1.6 is 1.3. So I need to find f of 1.3. The height for this interval is going to be f of 1.8 because that's the midpoint of 1.6 and 2. And then the last height's going to be the midpoint between 2 and 3, which is 2.5. So to find the height of each of these rectangles, I need to take the f of the midpoint. And I'm going to stop there, Jonah, just because I want to let you do that. That's the hard part. Once you get all these, you're going to take the area and add these up. So you're going to find width times height plus width times height plus width times height. And that's going to give you the total answer. So go ahead in the chat, Jonah, let me know how that feels. I don't have to stop there. I can keep going if you need me to. But I figured I'd leave a little bit of work for you. All right, perfect. So Jonah, let's translate this then to 1b. Let me go back to here. Okay, so 1b, the exact same question. Okay, meaning that our intervals are the exact same. So we have I have 1 to 1.6. I have 1.6 to 2, and I have 2 to 3. So nothing changes there. Still got those suckers. All right. What also doesn't change now, this is, sorry, I don't want to put equals. I just put an arrow. I'm going to start with the height. And what might benefit you actually is, let me put at the very top, area of trapezoid. This could have thrown you off if you weren't sure about this. So the area of the trapezoid is B1 plus B2 over 2 times h. In these problems, h is the same thing as what we were looking for as the width. The height is just going to be the length of the interval. Height is the length of the interval. So that's pretty easy to find, right? We already did that. It's the same thing as the width. So this length of this interval is 0.6, 0.4, and 1. Now the only other pieces we need then, right, are going to be B1 and B2. For each of these trapezoids. So the first base is going to be f of 1. The second base will be f of 1.6, our two endpoints. Here it's going to be f of 1.6 and f of 2. And here it's going to be f of 2 and f of 3. So to find the total area over that interval, you're going to take the area of this trapezoid, which is going to be f of 1 plus f of 1.6 divided by 2 times 0.6 plus f of 1.6 plus f of 2 divided by 2 times 0.4 plus f of 2 plus f of 3 divided by 2 times 1. Add all those areas together, it gives you the total area. So same thing, Joe. Let me know how that one works for you. How do you feel about that? All right, cool. Yeah, I know how that is, Jonah. Trust me, been there, done that. Same exact thought process for me half the time. Yeah, Jonah, no problem. Give me 1 second. All right, you wanted to go over 1D on Unit 5, Part B. Sure thing. Unit 5, Part B, 1D. All right, let me just open it up. Jonah, it sometimes can take a little bit of time, so just give me a second here. All right, Unit 5, Part B. You said you want to go over 1D. All right, so 1D says let h be a function defined by h of x equals f of x times g of x. And it wants to know, is it increasing or decreasing? So is h of x increasing or decreasing at x equals 0? Well, before we can do that, whenever we think of the words increasing and decreasing, we always want to be thinking about derivatives. Derivatives tell you if it's something, a function is increasing or decreasing. Because derivatives tell you the slope at a point. Right? A positive slope would mean that it has to be upward, be moving upwards, which means increasing. A negative slope means it has to be moving downwards or decreasing, right? So we got to find the derivative, and then we can analyze from there. So the derivative is going to be using product rule. So f prime of x times g of x plus g prime of x times f of x. And the question wants to know specifically at x equals 0. So I need to know, is it positive or negative at x equals 0? Right? So we take f prime of 0 times g of 0 plus g prime of 0 times f of 0. Now here's the key, Jonah, for this. It doesn't say anything about the actual values. It doesn't. We don't care about the actual values. All it wants to know is it increasing or decreasing, and we can do that just by finding the sign. All right. So for example, f prime of 0. Let's start there. We are given f prime, that equation, but we don't have a calculator for this question. So we're given what f prime of is, but we don't have a calculator. So essentially, here's what we're looking at. F prime of 0, you plug in 0 into f prime of x in the problem, and you get negative 5/4. Oh, you just get negative 5/4. So I guess this one was easy. I apologize. Just negative 5/4 is f prime. G of 0, you look at the graph, and you can see is 2. G of 0 is 2. Now here's where we just know the sign. We don't really care about what the actual value is. G prime of 0 is the slope of the graph of g at 0. So the slope of that tangent line has to be positive. So I'm just going to put a plus sign. You could put the word positive, whatever you want to put. Okay, I don't know what it is. There's no way for me to know exactly what it is, but I know that it's going to be positive. And f of 0 was given to me as negative 1. So I know that has to be negative. So Jonah, what you have then is going to be equal to negative 5/2 minus something. I know this isn't great notation. I guess the better way, let me just actually do this. Let me erase that. We're going to do h prime of 0 equals a negative, because it's going to be a negative value, plus a negative is essentially what you're having. Because this will be negative, that'll be negative, so negative plus negative. And that's going to give you a negative value. Negative plus a negative is still negative. So that gives me the information that I need to determine it's decreasing. All right, John, let me know how that was for you, if that was good. Yeah, absolutely, Jonah. I'm happy to help always. If you have any questions over the assignment over the weekend, please email me. I appreciate you participating, getting all your assignments in, doing a really good job. So keep that up, Jonah. It's going to go a long way. I know this is a crazy year for you, but yeah, I really do appreciate you putting in this effort. Time to go play Animal Crossing in my PJs. That's what Fridays are for, Jonah, let me tell you. That sounds like a blast to me. You enjoy that. I'm sure you are, John. I'm sure you're completely kidding. Wink, wink. How's it going, Damon? Sorry about that. I ran downstairs. I had to go to the bathroom. How are you doing? Hopefully you're still here and you can hear me. Jaden wants to play Hangman. I actually have some grading stuff to do, Jaden. Sorry about that. Hey, how's it going, Damon? What's going on? How you doing? So, Damon, just so you know, hopefully everything's going good for you. I'm waiting for any questions from anyone. So, if you have any questions on anything, let me know. No one else is in here; it's just you and me. So, the floor is yours. Any questions you have, I'm here to go over. Hope everything's going good for you.